The following presentation was delivered at the annual meeting of the Archaeological Institute of America held in Washington, D.C. on January the 3rd, 2020. Its title, From Debris Field to Battle Map, Artifact Dispersal Study in the Aegates Battle Zone. Since 2005, RPM Nautical Foundation, working in partnership with the Sicilian Soprintendenza del Mare, has been mapping the debris field caused by an ancient naval battle that concluded the First Punic War between Rome and Carthage. In recent years, our team has been joined by the technical divers of Global Underwater Explorers. The battle site is located off the western end of Sicily in the modern Aegates island group, as you can see in the top right image. Just below this, you see the debris field, which is located off the northwestern side of Levanzo Island, with a closer view of the central scatter appearing in the main image of this slide to the left. Note that the red and white dots represented here show amphoras, while the yellow triangles and blue pentagons, if you look closely, represent warship rams and bronze helmets, respectively. Before we take a look at this scatter in some detail, let me give you a brief review of what we found over the past 14 years for the benefit of those who don't yet know of our project. First and foremost, there are the warship rams. At last year's meeting, I showed a heavily encrusted view of this ram here, the 17th we have found, which has since undergone conservation and is now on display at the Colosseum in Rome as part of an exhibition called Carthage, the Immortal Myth. In all, we have discovered 23 warship rams in the battle zone, and we number them in the order of discovery, but don't always raise them in that order, which explains why one of the rams we raised this summer, Aegates 14, has a lower number than the one from last year. It's among the smallest we've found, weighing only 132 kilos. The team has also mapped more than 900 amphoras, including 75 Punic and 827 Greco-Italic jars. Additionally, we've found more than 30 helmets. With divers now using metal detectors, the number is sure to grow. The helmet we call the Griffin helmet must have belonged to someone important, with its elaborate crosspiece holder in the shape of a horned bird of prey. To the right, you see an example of what one of these crosspieces would have looked like. The crosspiece itself was retained by a small pin here, where the arrow points it out, and would have originally held a number of feathers. Since our divers are beginning to find more helmets buried in the sediment, as well as cheek pieces in pristine condition, it's likely there are many more than our small number of 30 might imply. This past summer, the divers found 2 sword concretions. The one shown here has a preserved length of 68 centimeters. The CAT scan to the right shows the hollow left by the blade, which tapers as you move toward the tip. The divers also found a few bronze coins, one of which is clearly a Carthaginian type associated with the First Punic War, bearing the head of Tanit, the chief goddess of Carthage, as well as a horse head on the reverse. For comparison, I present a pristine example from the Royal Collection of Coins and Medals in the Danish National Museum, which you can see on the left of the slide. While these new artifacts are certainly exciting, my focus now is on the debris field itself, that is, the spatial relationships between the various artifacts. My questions are as follows. How can we translate this pattern on the seafloor to the human events that took place on the surface? Can we see a battle line or the locations of individual ships? And what produced this particular scatter of amphoras and helmets? For starters, we must begin with Polybius. According to him, a Carthaginian relief fleet of some 200 warships was bringing supplies to their troops on the slopes of Mount Eryx near Drepana, modern Trapani. they overnighted at Marettimo Island on the 9th of March. And then, like all fleets on a long journey, they set out by squadrons on the morning of the 10th. When they saw a Roman fleet blocking their course around Levanzo, they formed as best they could into a side-by-side line and met the enemy head-on. From what we can see on the seafloor, at least 23 23 ships were destroyed, their rams plummeting into the depths, and their cargoes and men spilled into the sea. Ram positions that are in a line corresponding to a line abreast course around Levanzo Island imply the ships lost their rams quickly. Had the rams floated with warship wreckage at the surface for hours, they would have separated before sinking and would not be still in a line on the seafloor. But what about the amphoras? How did over 900 amphoras, the red and white dots on this image, end up in their current positions? To address this question, we need better maps than what I've been showing you. Let's focus on the area around the 10th ram we found, Aegates 10. Keep your eye on the yellow triangle at the center of the white rectangle as the scales change. If you can't see it now, you will soon. At this scale, each red dot still measures 25 meters in diameter, and the triangle, representing Aegates 10, has sides of 54 meters. See that area just to the north of the ram that looks like a cluster of amphoras? Well, here's what it looks like with the red dot sized to 1.4 meters in diameter. Suddenly, that cluster goes away. In reality, the amphoras are not at all clustered together, like you'd find if they sank inside the hull of a ship. You can see why we thought the pattern might be produced by deck soldiers throwing amphoras overboard as they went into battle, or more likely, as they tried to escape after their ships had been damaged. But then, look at the helmet 65 meters to the northwest of Aegates 10. That's more than 2 ship lengths away. How did it get there? Keep your eye on it as I shift the view down 80 meters, like so. And what about the scatter of helmets a ship lengths away to the southwest? Could currents account for this cluster? Was the one to the north from a Marine who fell overboard or threw it off after clinging to a piece of wreckage? This past summer, after years of pondering what these artifact patterns meant, we carried out an experiment in the battle zone designed to record the behavior of artifacts dropped from the surface to the seafloor in varying degrees of known surface current. The exercise was funded by a grant from the University of South Florida, to whom we are all grateful. Let me explain how we designed our drop experiment so you can judge our results for yourselves. First, we limited our drop to 2 artifact classes, Greco-Italic amphoras and Montefortino helmets. 6 amphora replicas were produced for us by Mr. De Patti of Ceramica Artistica Marsellese, who used Tuscan clay fired to a temperature of 1,000 degrees Celsius. While the shoulder carination of his jars were not as sharp as the mid-century Greco-Italics we were finding, both the exterior dimensions and the capacities of the replicas matched the average of those we were finding in the battle zone. In short, they provided good stand-ins for the real jars. We gave each of our amphoras a unique number and fitted to its neck a mini transponder that we made neutrally buoyant with the addition of floats on a polypropylene line. The transponder allowed us to track the jar's movement toward the bottom on the ship's positioning system. We sealed those jars destined to hold olive oil or grain, like the ones you see here, with acrylic paint, and that's why the inside of the central jar is gray, and the inside of the jar on the right, which is receiving olive oil, is white. 3 helmet replicas were made out of steel by Deepika Industries of Meerut, India. Since these replicas were lighter than the ancient ones from the battle zone, we added 2 pounds of lead to 2 of our replicas by gluing a sheet of lead to the interiors. The final weight was about 2.14 kilos, as opposed to 1 1/3 kilos. We tied transponders to these helmets as well, which were fitted with polypropylene lines and floats, just like the amphoras. For our first test, we dropped artifacts, like the helmet, to the seafloor one at a time, so that we could chart their fall through the water column. You see here in the left image the path taken by one of our helmets on its route to the bottom. The readout gives the final resting latitude and longitude, as well as the depth of the artifact. We filled the amphoras with 3 different contents, namely fresh water, which is equivalent to wine in buoyancy, or very nearly so, olive oil, and durum wheat. In the first set of drops, we used only water and olive oil, shown in the 2 amphoras on the left. Once the artifacts had been dropped and their positions logged, we launched the ship's ROV and double-checked the latitudes, longitudes, and depths of each one before retrieving them, which was a good thing. We found that the ROV's instruments produced more accurate positions than did the mini transponders. Here are the results of the first test. Now, we made our first drop before lunch, and even though we couldn't tell it on the surface, it looks like there was a northwest current that swept the water amphora, A3, a distance of 32.4 meters to the southeast. During lunch, the current under the surface apparently changed direction. We couldn't see a change on the surface, because the rest of the afternoon drops were carried toward the southwest. Do you see what happened with the heavy helmet H1 and the oil amphora A6? There were some interesting results here. Look at what happened to the amphora filled with olive oil and with fresh water. Because the oil is lighter than water, with a specific gravity of 0.9 as compared to 1.0, its jar is slightly more buoyant in the water, and so A6 was carried almost 11 meters further from the drop point than the water amphora A2. We can see something similar with the helmets of different weights. The lighter helmet, H3, traveled almost 3 meters further from the drop point than did the heavier helmet, H2. The results of our second day of testing were quite similar. Once again, the more buoyant oil amphoras traveled further than did the water one, and the lighter helmet farther than the heavier one, but not by much. We found it interesting that the strong current on the surface seemed to have had a minimal effect on the overall results when compared to the previous day of low surface current, implying that that current layer was not very thick. When we dropped an empty amphora in the water, we expected it to float, which it did. You can see in the left image. But we were unprepared for the behavior of the wheat-filled amphora. It too floated for about an hour before we fished it out of the water, almost a kilometer away down current. Since the specific gravity of durum wheat is around 0.8, even lighter than the olive oil, our replica, when filled with it, was almost neutrally buoyant. It sank only when water seeped into the jar and displaced some of the air. How fast this occurs depends upon the manner in which the mouth of the jar is sealed and whether or not the amphora is lined. For example, our replica amphoras soaked up liquids like sponges. The grain amphora that floated 916 meters soaked up 2.7 kilos of water during its little voyage. Look at the color difference between the 2 amphoras in the left image. The redder color of the amphora in the foreground is due to the water it has soaked up. How the jars were stoppered must have also affected their rate of sinking. We capped our amphoras with leather skins, which made a pretty tight seal, but the Carthaginians might have used cork plugs, like these, found with 2nd century Greco-italics on display in the Marsala Museum. To see how close the grain-filled jars were to the sinking point, we ran a series of tests back at the dock. It turns out that with these Greco-Italic amphoras, it makes a big difference if the grain is filled to the rim or to the base of the neck. Our amphora number 1, when filled to the rim, immediately sank, as you can see in image number 1. When we removed the liter of grain, as illustrated in the second image, so its level was at the base of the jar's neck, the amphora just barely floated, as seen in image number 3. Still, it stayed on the surface for about 9 minutes before it fully sank. Because of evidence like this fresco in the Vatican, one normally thinks of grain being shipped in sacks. Is it possible that in this instance the Carthaginians felt it safer to place their grain in stoppered amphoras, particularly if they were tied down on the decks of warships out in the elements? It's impossible to know for certain, but Polybius wrote that grain was among the items shipped with this fleet. Now we come to the conclusions. Whatever they contained, many of the amphoras scattered across the site held contents with specific gravities close to 0.8 or lower, surely dried goods and perhaps grain. While the speed at which a grain-filled amphora would sink depended on a host of factors, we saw that a well-sealed amphora filled to the base of the neck could float for a kilometer from its point of entry into the water. This said, the difference between floating and sinking was not great, and many amphoras likely sank more quickly than this. For less buoyant objects like helmets and amphoras full of wine or oil, it seems that the surface current didn't much affect their trip to the bottom. By this, I mean they were not displaced far from their drop points. In 80 meters of water, most items we dropped traveled between 16.5 and 32 meters from the drop point. And finally, we found that when a mix of 5 helmets and amphoras filled with oil and wine were dropped at the same time, they landed relatively close to one another, ranging from 2.8 to 16.5 meters apart, with an average spacing of 8 3/4 meters. We're hopeful that further statistical analyses will tell us more about the patterns of spacing between artifacts across the site. Before concluding, I'd like to share with you the first tangible results of our discovery. When we looked at our survey map and considered that many of the amphoras may have floated some distance from the ship that originally carried it, we concluded that we either had a number of unlocated rams to the west of the scatter or to the east of the scatter. Since the currents we experience generally come from the north and northeast, we decided to look east of the scatter in areas where there were amphoras to the west, but no rams to the east. In the last few days of the season, our hunch paid off, and we located 4 new warship rams, which are pointed out in the right image. It's beginning to look like we had a northeast current on the day of our battle, and that at the battle's conclusion, after the rams and helmets had settled to the bottom, the sea's surface was still littered with bobbing amphoras blowing toward Marettimo Island, until finally, overcome by the weight of water seeping into the jars, they too eventually disappeared from view. Remember the scatter of helmets to the southwest of Aegates 10? If we're right about the current, and let me add it in here, this scatter might represent soldiers who were clinging to wreckage after the bow of their ship sank. While we may never explain every pattern in our debris field, our little drop experiment has started us thinking in the right direction, in human terms, and has given us a working hypothesis to test in future seasons. And who knows, a little experiment just might help others make a sense of loosely scattered amphoras found outside the boundaries of clearly defined shipwreck mounds. They just might be the result of amphoras that floated for a while before sinking. Thank you for your attention.